Hello and welcome to another video from KOJRO, and this time it's about testing this signal generator as a source for my amplifier projects. I'm going to measure both the inputs and the outputs on my DV something oscilloscope that I bought some years back. I also have some separate videos about this, and I'm going to test a bench test with this as a signal generator and just this as the output load on the amplifier. And this I have shown you once before. It's 3 times 5 watt 3.3 ohm resistors, so this each side is about 10 ohms, and it will be able to sink about 15 watt for a long period of time, but for a short period of time this will not die if I use 20 to 25 watts on each of them, and I can even cool them in water and stuff, and they will be able to sink much more than that. But for this project, 2 times 15 watts, 30 watts, that's quite a lot of heat we are going to produce, and our heat sinks is not up to the task, so that has to be for another day. So this is just to test that the amplifier doesn't have any weird distortions on the output, and that we will be able to determine with this. I'm also going to determine if there is some DC output on the speaker output. If you have a speaker connected and there is some DC regarding to ground or relating to ground, if you have just a couple of millivolts, there will run a constant current through your speaker coils. The speaker coil will of course be offset, either drawn in or pushed out, so it will have less room to swing, but also the coil will heat up really fast. So if you put DC on a speaker coil, it will be the certain depth of that speaker. And I'm going to test this with my really old homemade speaker boxes. I actually made these boxes together with my father when I was about 13, and they didn't look really good back then. I did some fixing of this some years later. I put on this fake veneer with just some plastic wrapping thingy, and I changed the elements also. About 3 years later, I think I was about 16, and I did the rebuild that I actually have now in these speakers. I did in 1994, so it's quite some time ago, and it's done with SEA's elements. It's a 2-way speaker with an 8-tone bass midtone and dome discount driver, and it has the filters and everything set up inside, and it's partly tuned. It's an open ventilated case with a bass tube that leads out the lower frequencies. And these speakers sounds quite okay, but it's 5, 6, 7 years since I had them last into action, so I'm looking forward to test them again. Hope they have not died because of some external circumstances. You have these cones on the speakers, they can rot away on you if you are unlucky. I actually have some F3 speakers, it's a Danish brand, that the speaker rubber dome actually it just rotted away, so I replaced these elements several years back. They are in the basement of my workplace. And I do also have some other speakers that I will be able to test here. It's some from Castle Audio in UK that has made those that I'm not using. I also have some Castle speakers down in the basement in my normal work area. And I have some Yamaha speakers down in my the garden shed. But I'm digressing. And by the way, I'm using the glasses not because I'm old, but because it makes me look more intelligent. So let's just crack on. We do have to connect this thingy with this thingy to see what we get out signal-wise. This is from my bench, and I'm going to show you some things that I'm going to do to test the amplifier with some actual signals. And I do have here my Android phone. This is an old Nokia phone that I use as my secondary phone, and I have this application here that is giving me some options for acting as a function generator. And first I'm going to how do I do this? I chose this one and minus. So then I have 1046 and 1046, and that's C6 on both start and end frequency, otherwise it will do a sweep. And we test with sine wave, and yeah, you probably can hear that. And this is as close as you can get to a test signal. Back in the day, it was sorry, I touched something here, like so. That should be the test signal. Back in the day, when in the 70s and 80s, when they had this test picture on your TV screen, it was a 1000 hertz signal that was meant to be used as fault finding and as a test help for adjusting TVs and stuff. And that's why you also have this geometrical picture where you can see the colors, the filters, and also the saturations, and you can have the test sound on your TV. So actually you can debug your TV if you turned it on when it was outside of the normal transmission times. And this has a 3.5mm jack. Last time I told you that the signal lead that I made was not good enough, but I've made a backup, and that's this one. It was a 3.5mm to 3.5mm lead that I just cut off, and I dismantled it, and I've done some soldering on this. And here is my DV something 2-channel El Cheapo Chinese oscilloscope. I have never used this scope for anything with audio before. Normally I prefer to use an analog scope to analog equipment, but this is the only one I have as a portable device that can be brought here. And this is the other end of the wire that I cut off. And I can of course just connect this up. It will be a bit ad hoc in this, and you have the common ground wire. Like so, and connect this like so, and start. Oh, you can see here at once it come. I actually here had difference in the signals now. If I try press auto, I will get this, yes, and there is only signal on one of these. Why is that? Yeah, he is slow. It takes a while before he discovers that the fault is just that two patterns are laying on top of each other. It's triggering. Maybe they're just so close together that they are not showing any difference. How do I do that? I take this one and move it about, yeah, like so. So now you can see both of them. And when I test this, I of course need to test it with a stereo signal, but both modules will be fed with the same sine wave when I do the measurements. And to do the measurements, I will introduce this one, and this is the same unit that I used before when I tested the power supply, where I found that this was, yeah, it was loaded down too heavy. And this is 3 times 3.3 ohms, and they are 5 watt each. So 15 watts into each channel in 10 ohms is what I'm going to sync with this one. And of course I can, yeah, for a short period of time it's no problem to take this to 20, maybe 25 watts, but for a longer time I have to sync this in water or ice or something if I want to have that much load. But it's not going to be a problem. We are not going to load our amplifier down as heavy as that. With the heat sink that is on it now and the efficiency of this speaker, if I take and take 30 watts, that's 2 times 15 out of this, and the heat sinks and an efficiency of the amplifier maybe about 50% something, I will need to sink as much power as this into the heat sinks. So I will need to connect something up to this, and this is okay. I need to connect together the ground wires on this, and I need to make some kind of arrangement to put both the ground wire for the speaker output, that's this one, and for the power input into the same grounding wire. But otherwise than that, we are ready to do a test. And of course, if this works out fine, then the next line of test will be to don't use this as a signal generator, but use it as an actual music input. I can play some music on this and use the same connector, and I will connect up my speakers. And the speakers I'm going to test here is some old ones. It's speakers I had since back in the day. So I'm going to tell you more about them. But let's get on with the tests. I don't think I need to set anything more up here. I can actually try here to, how high will you go? No, it's peak value of 765, and if I, yeah, now it's cranked up all the way to the top on both volumes. So peak to peak value 7.6 milliwatt, and I not checked the input sensitivity on this amplifier, but of course the normal thing is about from 1 to 2 volt for a full output. So that means if I deliver this kind of signal, it should give out a lot of amperage on the output. So I need to tune this down when I test. Yeah, now it went down to 440. I touched something. But this is the 400 signal. 441 Hertz. But enough jabbing about this. I'm going to get the amplifier connected up here, and I'm going to connect up things for getting this tested. Yeah, I'm not totally finished with connecting this up, but I'm almost there. I do have some, yeah, I have to connect up the signal wire. Now this is real close up, but let's see what we have to deal with here. I need to, yeah, I need to space out this one to get it to both amplifiers at the same time. And I need to do that with a ground wire. There I can use another wire. I have this one that I can use. I can connect this one up to ground, like so, between these 2 points. This is not this is not a good signal path, but we have to make do with what we have, and I need one to connect to my scope probe, and I need to dismantle this wire more so that I can connect the signal wires here to both. Yeah, like so. And of course dismantling this much of a signal wire is not always a wise thing to do, or it's never a wise thing to do, is a better thing, I think. And this one was ground. Maybe just cut this a bit. Now I have 3 wires of different thickness into the same connector here. That might not also be a good thing. Seems like I will be making contact, so yeah, and there are markings here on the PCB, what's the input and what is the ground wire. So now I have connected ground together, I have connected both the signal wires, so this should be okay to plug into my phone. I do have this one. I have connected all the grounds into this one, and of course this is not a good signal path either, because in an amplifier like this all the ground should go to one single connection point that is as close as possible and have the same wire length to everything, so that you will have a good ground, so that you will not have introduce more hum in the system. And hum, that's the radiation you have in the air from the 50 Hertz. And yeah, what will I do to, yeah, of course, I will just connect up, make sure that I don't short out anything. How will I do that? We have the ground here. I have these wires here, and I need to have this reach a bit so. This is the speaker, and this is this speaker. Like so, and ground, and you have the AC in, and it's nothing here that is loose or can be shorted. My fuse is okay. This is my rectifier bridge is okay. The connections here for the rectifier bridge is okay. And I have my oscilloscope. Let's make sure that that is not making havoc to anything. And if I connect this like so, I will be able to put this into here to check the input signal. Maybe I should have clamped this together with something and just use the other one, so I might just take a short piece and put into the input signal here to see what we got. And of course also, now I'm connected this as a stereo output. I should have connected this as both signals into both inputs, same signal into both inputs, but I didn't do that, so we have to just make do with what we have. This might seem a bit chaotic, and I can assure you the only way it's like that is because it is. Yeah, the signal wire goes into there, and I'm going to use this scope probe, and this is the red one, and the red is probably channel A. Yeah, I'm going to do it like this. Use this ground probe and this signal hookup. So this should now be the input and this is the output. We have to turn everything into a nice test here and use this 1 kilohertz equality, turn volume way down, and it's still a bit sound. Yeah, let's hope that's a weak signal. I probably don't have if I turn this a bit up. Yeah, like so. It's 1.5 kilohertz, so that's okay, and I'm going to turn it down like so. This is a very weak signal. Let's start with that. I get everything here connected up. I'm not connected this to anything. I'm going to use this later. I'm going to have this free. This is my scope probe, and I'm going to put this one, and it's still low battery and it's hidden beneath here, but I'm going to use this to measure that I have voltage into the amplifier, and I do think this will run the full output now at once because I have not turned down the variac, and I have this now and a low signal input, and I have my probe here to measure here against the output on the amplifier. So turn it on. Oh, maybe I should put in the AC line. The fuse did not blow. I do have an amplified signal here, I think. Yeah, what am I measuring? I'm measuring 384 out and 13 in. If I turn this a bit up, I have a peak to peak now on about 1 volt. 1.4 volt. If you look on the output of the signal, it looks really clear to me, but it's 2.3 volt peak to peak. And it looks like it's symmetrical, so that means I don't have any DC bias on this. It seems to me like it is, yes. And if I produce some more, I have an input signal here. Nothing should start to get hot, not on this. It's not hot yet. I do have here 4.3 volt peak to peak on the output, and I have about 120 millivolt on the input. Now I have 11 volt peak to peak on the output and 317 on the input. It still looks good. Nothing is getting hot as of yet. But 11 volt peak to peak, this should be quite the audible signal. But I can turn this down and I can try to because now I have taken away some limiting on the no, I have not. I have to. This is the absolute maximum. I do have 16 volt now on the output and 400 and something, 450 millivolt on the input. It still looks stable to me. Yeah, now they are starting to get hot, and these two is starting to feel it. (16.2). 16.2. So I think this really looks good. I think we can say that we are ready for some action. I can see what's going on the. I should measure what's the input voltage. That there is no. Yeah, it's when it's loaded now. It's about 76 volt. Yes. One final measurement. The scope. 16.2 still. 16.2. Yeah, then it's I think time to get cracking on this. Yes, now I have connected up a speaker wire and the speaker wire here, and I have the ground connections for the speakers here. I will show you the speakers in a minute, but first I will do a sound test. And this microphone is not ideally placed to pick up the sound for this, but let's hear this. I've actually done a quick test just with the tone generator. I'm turning on the Variac power, so now the amplifiers are live. I do have my phone connected here and it was turned all the way up. We can't have that. I do have an MP3 song here that is a mod that should not be copyright protected. This is actually the music from the game Tetris. It's an old Russian folk song that's called Korubieni or something like that. Oh, there was a pop. I'm only hearing something from one of my speakers just now. So there is something that's not right, or maybe this mod is wrong. Oh, that's not good. Now it's on, and it actually got a bit of hum here. Maybe I broke something. The plus connector was loose here. It's actually, when I turn on and off the signal source, it's popping in the speakers. That could be my phone. It sounds totally fine. I will check to see if I find something other to play. Oh, I have the No Name song here. This is the normal song I play at the end of my video and the start. This sounds awesome. These speakers are really good. I'm going to show you some picture now of the speakers. As you can see, they don't look the best. They are quite old. I made these speakers with my dad when I was 13, and then they was just grey boxes and not very well cut. I remember my dad complaining about that his blade for the circular saw was not the best. But we screwed them together, and I put some old speaker elements in them. These speaker elements were salvaged from old TV sets, and when I was 16 I replaced them with some other speakers that was a tad better. One of them, I think it was the mid-level and bass speakers from a car stereo thing. And then in 1994, when I was 24 years old, I replaced them with the element that's in here now. So these speakers has been playing since 1994, on and off. They have not been used now for, I think it's... I remember I did a walkthrough and repaired some damage to them in 2015, and I used them some years later. But it's 12 years since they got any service, and they work just fine. And the elements in this is SEAS, the Norwegian manufacturer. They are 8-tom drivers, and I have bus drivers, and I have the tweeters that is on dome tweeters, and I think they sound really good. They have a bit lacking in the mid-tone, as they are 8-toms. You don't get that, but I think they play really good. Oh, and I can hear some hum when they are. That's probably, it's a lot of loose wires here and stuff, so I'm totally fine with this being some trouble, and I have to look into that if this is the signal source. If it's not, when you turn on and off the audio to have the popping sound. But this will be the last part in this series, and these are, they're not burning hot, but I won't keep them on for much longer. until I get a good heatsink. But this will be the last part in this series. I will make another video when I have get myself back on the feet and can make some more improvements on this. I'm going to find a box. I'm going to mount on some other heatsinks. Otherwise, I'm going to use all these components as they are, shorten the leads and make some connectors and stuff. And I'm going to just upgrade this with a very basic preamp so that I can use this standalone, and a Bluetooth receiver so that I connect it to my phone and can use it when I work and other stuff. This will not be a living room setup. So that's it. Thanks for watching. This is the fourth part in this series, and I do know that this series has gotten kind of long, but some of you, not very many, very few actually, has stayed till the end. But I hope you got some pointers. And can I recommend this set? Yes, absolutely. To the price, you are getting a good kit. It plays really well. And I'm going to let it cool down now, and I'm going to listen to some other music that is sadly copyrighted, so I can't play it here. So, thanks for watching. See you in my next one. My next one will be computer related, I think.